Oh, hi guys. It's really nice to meet you today. And today I'm going to have a brief introduction to sorting because this is very important in algorithms and maybe many of you have noticed that. But since maybe a lot of you had, this is the first time of you to just start a program and I was pretty confused by my time. So I think some explanation should be made. And the first thing is, why should we sort? As it makes the data more constructed. And what does it mean? So for example, there are a list of tasks that you are going to make. And maybe one of the best way to do all of these things is to handle it one by one. But suppose all of the events are sort of mixed together and you don't know where to start. So every time when you started doing any project, you have to search one from all of the events and finish that. And the next time you have to look about all the events you have and finish, find another. I don't think it's really convenient because you may feel like it might be better to just do all the events in a sort of order. And the second example is suppose you are a teacher and you are on a roll call for all the students that shows up in your classroom. And their names may be Amy, Betty, or Mario. And maybe some of them don't show up and maybe they're later. And you ask them their names are and you add them to the list that you were just calling for students. But if all the names are organized, it's very easy for you to find where the name is because it's over there. Betty is just a second and you take it to ritual. But if all the name lists are poorly organized, you have to look over all the names. And if suppose there are a lot of students that don't show up earlier, it might create a lot of trouble for you because it's you, the teacher, will mess it up. And that's it. That's a general idea that sorting provides you with some basic information that you might want to do in the later algorithm instead of just doing anything from scratch up. So it is really important. And then it comes to sorting, because this is an algorithm. And if you are given an example about what to sort, there are certain things that are very important because it's an algorithm, and the most important thing would be what to expect it from the output. What should it be like? It in an easy case, it just might be a list that's containing all the numbers. Well, the first one is the smallest, and last one grows larger and larger. And the input, because if you aren't given anything, you just cannot do anything. Because that's it. And the input might be another list that are not organized or unsorted, and your goal is to make the unsorted list into a sorted one. And oh yeah, sure. Let's just take this as an example. If you are given such a list, 9517, and your mission is to make the list sorted but ascending in an order, and what should you do? If you are given a pen and paper, you may want to do this. Suppose firstly find a space that you are going to write your answers, and then look over all the numbers in the list and find the smallest. Oh, it's one, and you copy that into the first number of your result. And for your own convenience, you might cross it out to make it out of sight and out of mind for the next loop. And this is the first step. And then try to see that again. Oh, 9, 5 crossed 7. and smallest will be 5, and cross 5 again. Because they're cross and you don't mind what they were previously. And do it again. 9, 7. 7 is the smallest. Cross 7, put it into the result. And only thing is 9, cross 9, put it into the result. Yeah, so that's the general idea of the code. And if you are used to Python, it's really convenient. Let's just do it as another example. This really works. And suppose A, the list A is a input that you want to do, and put all the sorted numbers into the result. And what should you do? Oh yeah, first find a number, let's say X is the smallest in the loop A, and put it into the result value. And then cross, what do you mean cross the value from A? Just remove. And that's it. But this is just one loop. So how do you do to finish all of them? Just to make it in terms and to do it separately each time. And this is the idea. Look, there are length of A of elements. You remove the minimum of it each time. You put it in the result and remove it from the original list. And this should work. And let's see the result. And as you run it, look, 1, 3, 4, 6, 9. It works. And this is a first scratch example of how to sort something. Maybe you have noticed that find the minimum of a value in the list is not really convenient. And with the course going by, you might know some easier ways to make it more computing efficient. But anyway, you have this is the first code about how to sort, and I hope you'll learn something from it. Thank you so much.